We are going to look at a quadratic function in what is known as vertex form with this particular example. And so when your quadratic is in vertex form, whether it's written as y equal or in this case k of x, function notation, then it's going to be in the form, we say a times x minus h squared plus your k value. And what's nice about that form is that you can look directly at that to determine your vertex. So your vertex is always written as the h comma the k value. Okay, so notice when we compare this vertex form in our particular case to the equation that we have. Let me go ahead and write it underneath here. So a times x minus h squared plus k. So when we first look at the h value, notice it's minus h, and so you have to match that up, and so the minus signs match up, which means that your actual h value is positive 1. What I always tell students is just take the opposite of what you see. So if you see a minus 1 in the parentheses, you take positive 1. If you were to see a plus 1, you would take negative 1, because this particular part here is telling you to take the opposite. Now, with your k, you're going to take directly what you see. And so with your k, if there's a minus, you'll take it with that. It's directly what you see. So in this case, my k value is negative 3. So that would be the vertex of this particular quadratic. Now, since I know we're going to be graphing it, I'm going to go ahead and come down to the graph and place that point on my graph so that it's ready to go. Step 2, we're looking for x-intercepts. In order to find x-intercepts, you have to let your y value be 0. So in place of my k of x, that's my y value, I'm plugging in 0. So I get x minus 1 squared minus 3. And again, the nice thing about this form, don't FOIL this out. We're just going to simply move the 3 to the other side, and we'll use our square root property. So the way we cancel a squared term is we take the square root, but anytime you square root both sides of an equation, you have to consider that there are both positive and negative numbers that could produce that. So we put a plus or minus. So we get plus or minus the square root of 3 is equal to x minus 1, because the square root canceled the squared power. And then finally, if I add 1 to both sides, then I get 1 plus or minus the square root of 3. So they're going to first ask you how many x-intercepts. In this case, I have 2. And then they're going to ask me to write them as ordered pairs. They do not want decimals. So one of my x-intercepts is 1 plus the square root of 3, comma 0, because the y value is 0. And then the other x-intercept is going to be 1 minus the square root of 3, comma 0, just like that. Okay, so then finally they asked me to find 2 points on the graph other than my vertex and x-intercepts, and then they want me to draw the actual graph. So what you plug in is really up to you. In this case, it's going to be easier to choose x's to plug in. I would choose things that are easy to plug in. So, for example, if I let x equal 0, that's going to be real easy to simplify. So 0 minus 1 would be negative 1, and when you square it, it's positive 1. And then 1 minus 3 would leave me with negative 2. So that would be one ordered pair. When x was 0, my y was negative 2. So plot that there. And then another easy one that I'd probably plug in is positive 2. Or you could even do positive 1. You know, whatever it's your choice. Doesn't matter. 2 minus 1 is 1. 1 squared is 1. When I take 1 minus 3, I'm left with negative 2. So when I plugged in positive 2, I also got a negative 2. So remember, with quadratic functions, they are U-shaped graphs. So connect the points and we have that particular graph.